This episode of the EV Resource Podcast is brought to you by Titan Auto and Tire. Titan has some of the very few independent auto repair shops in Central Virginia that are qualified to work on EVs and hybrids. And from hybrids to Hummers, they fix everything. For more information and to schedule an appointment for your vehicle, go to TitanAutoTire.com. Coming up this week.
So the AI process is really optimizing basically everything that's inside the cell stack and really helping navigate this very, very, very large design space of possible battery materials.
Well, hello, friends, and welcome to episode 170 of the EV Resource Podcast. I'm Zach Hurst, and each week I bring you the latest EV news, information, and interviews with industry experts. This week, I'm sharing with you a conversation I had with Jason Koeller, co-founder and CTO of Chemix, a company that is revolutionizing EV battery technologies through the use of AI. Traditional battery development is slow, labor-intensive, and expensive. But with the use of AI, Chemix can reduce that development time by as much as 10x. I am so fascinated by this use of AI, and I know you're just going to love what Jason has to share. Before we get to the podcast, though, I want to give a shout out to TireRack.com for partnering with EV Resource to offer a deal that will help you get your car ready for the winter season. Right now, if you use the link in the show notes, you can get select automotive lighting and wiper products up to 30% off. This offer is valid now until December 15th, so do not wait to confidently handle the upcoming season with new lights and wipers for your car. Jason, I want to thank you for taking the time to come on the EV Resource Podcast. I am absolutely fascinated by Chemix and really excited for you to share with the EV Resource audience all about what you and the team are doing. Before we get into all of that, though, I'd like you to start with your background and what led to the conception of such a revolutionary idea.
Sure. So my background is really a combination of a bunch of separate topics, but for Chemix make a lot of sense together, which is sort of fundamental physics, experimental battery science and battery engineering, and software and machine learning. So I've had jobs and roles in each of those categories separately. And then Chemix is really the first time, combining all of those things together. So Chemix has been around for a little over 2 years. And the story of Chemix is a former colleague of mine from a previous company, Kai-Shang Lin, who I met about 5 years ago. And I reconnected after we were no longer working together, and basically decided, that we wanted to try speeding up battery R&D with a vertically integrated approach, where not only do we do the battery experiments, but we also have the software and machine learning stack on top to basically process all the data and speed up the battery development process. And so typically, you have companies that are just doing battery R&D kind of the old-fashioned way without this kind of AI data-centric approach, or you have software companies that, build software, AI as a service products, machine learning as a service products, and these are software products. But Chemix is really this vertically integrated, hardware and materials plus software and AI. And so my background is kind of in a combination of all these things. My co-founder's background, who's Chemix's CEO, named Kai-Shang, is a battery chemist and organic chemist by training. And so again, kind of this fundamental combination of these two fields. And the reason to do it this way really came from both of our previous experience. I had sort of worked on AI before and really seen the power of it, but the bottleneck is always the data quality and the data availability whenever working on any of these problems that are really grounded in the physical world and require physical experimentation. And so by vertically integrating all this and doing it in-house, we basically have the opportunity to generate much more data, much more high quality data, and control the data infrastructure much more, deliberately.
Yeah. AI is only as good as its training.
Exactly. That's exactly right.
So, that's really awesome. So, Jason, Chemix has been operating for 2 years or so, which is still very early for most startups. But I found it interesting that on the web page, 2 out of the 3 prototypes that you have listed actually say that they're ready for shipment right now, and that the third will be available by the end of this year. That's incredibly fast, especially compared to other companies in the battery development space. Would you attribute that to the use of AI, or is there something else going on as well?
Yeah, that's a huge part of it. I mean, really, the whole purpose of the AI from our perspective is to speed up the development process. It basically allows us to computationally screen many, many hundreds of thousands of candidate designs and recipes per day. Then we can focus our experimental efforts on only the most promising ones. And then this happens every day at sort of a very rapid pace with, without delays and intermissions. And so it's that compounding effect of continual testing, continual improvement, continuously forecasting how long batteries are going to last, and then using that information to update the data set and then designing the next set of experiments the next day. This sort of battery development on autopilot, if you will, that allows for very rapid improvement. Yeah.
That is an incredible pace. I mean, just when you're saying that, my initial reaction is, how can the few of you that are human working on this keep up with all of that and kind of take the results of whatever is generated and then work with that to come up with something that would be viable for the mass market? And I'm making a big assumption there. I'm assuming that that's what you guys are ultimately looking to do with this business. Am I off on that? I mean, that typically
No,
when I've
that's right.
talked with other companies that have worked in the battery space, it's all about providing solutions for as many customers in as many potentially different market segments as possible.
Right. And there's another key bottleneck, though, which I think isn't even talked about as much in terms of getting new batteries to market, which is really the manufacturing scale up part of it.
Mm-hmm.
And so, I mean, there are many battery startups that can, come up with impressive specs on paper and maybe some very, very small prototype designs, in a few years.
Mm-hmm.
But getting large enough batteries that a EV customer could actually build a pack and actually build a demo vehicle with those.
Yeah.
That takes a very, very long time. But we made the conscious decision from day one to really focus on battery chemistries and designs that could be mass manufactured using today's manufacturing equipment. So we don't have to rethink how to manufacture anything. As soon as our designs are finished from our internal development powered by the AI process, we can then seamlessly transition those designs to our manufacturing partners and basically get those batteries made at larger sizes and larger volumes. And that's another kind of acceleration in the full product design loop, because that means we can get the batteries in the hands of customers and we can test them in the customers' vehicles much more quickly, get the feedback from that, which of course is going to be, somewhat distinct from the results from, pure laboratory testing.
Absolutely.
And then iterate best on that as well.
Yeah, you absolutely have to be able to test in real world situations to really show the viability of the product in that type of application. But you're right. I mean, even then, scaling that is one of the more challenging aspects of the whole process.
It can be, yeah, especially for certain chemistries and certain designs that really require, a redesign of the manufacturing process. So whenever people are talking about, I'll just say, first of all, there's two maybe definitions of scaling. One would be literally the size of the battery. So making small batteries, by hand versus making like large batteries that you could put in a real, EV. Until you've made those large batteries that can go in an EV, you haven't, by definition, you haven't been able to test it in the real world. Sure. But even once you've made those, then of course, yeah, you've got to make lots more of them, which can be challenging as well. But we focus, like I said, on designs and chemistries where at least the scaling from, small to large and then large to more large is not a huge risk, because it's been done before with, different versions, not the versions we're working on, but with different versions. Yeah.
Mm-hmm. So you've mentioned chemistries and whatnot, and I don't want to assume that anybody is as knowledgeable about batteries. You guys have on the webpage 3 different variations of batteries. I'm assuming that they're designed for different use cases because of the different performance metrics that are involved. Are you primarily looking at batteries that are in the traditional sense, have a cathode, an anode, and an electrolyte, or have you gotten into the magic of solid state batteries at all that we keep getting promised, but it seems like it's always a couple of years down the road?
Right. So solid state batteries, we're not working on solid state batteries. Solid state batteries are one of the designs that I was alluding to that don't fit the mold of current manufacturing. And so the scale up challenge for those is enormous. And if it happens, it'll be a very long time. It'll also be quite expensive. And trying to forecast how long it will be before solid state batteries are available in mass quantities at high quality and at low cost, that's very, very challenging to forecast how long that will be, but certainly decades, if ever.
Right. I want to dive into the 3 battery prototype variations that you all have developed. They're named Sapphire, Jade, and Opal, which whoever came up with the naming, I absolutely love that. But can you explain how they are differentiated and share the specific targeted application for each of them?
Yeah, so first, I just want to mention these are, I would say, categories of product.
Okay.
They're meant to be directional, and they do refer to specific batteries, but for different customers and different applications, usually they're customized and tweaked. But broadly speaking, so their families, broadly speaking, Sapphire is targeted at ultra high performance applications where you really just need maximum amount of energy per volume and per weight, and they cost a bit more as a result, and contain all the elements that they need to contain. So they contain nickel, they contain in some cases cobalt, and are really designed for high performance applications. Then Jade is applications that are less demanding on a energy density basis. They're more sustainable because they don't contain nickel or cobalt, and also have a better thermal profile, so that they tend to be a little more resistant to heat and to incidents in terms of like puncture and that kind of thing. And then Opal is kind of next on the list. Would be the most sustainable, containing the least amount of scarce minerals, be the cheapest option, and for applications where the energy density is even less important. Of course, still important. At the end of the day, a battery is supposed to carry energy, so you definitely need energy density.
Certainly.
But kind of third on that list. And so really they serve different families of EVs. You can think of sports cars or high performance motorcycles for Sapphire. You can think of mass market EVs, or sedans and SUVs for Jade, and then you can think of more economy, smaller cars with kind of less range requirements and a lower price point for Opal.
Sure. That makes sense that customers would want to tweak the design to fit their needs specifically. I'm curious if requests from customers include specific form factors for the cells. Like, how much does form factor affect the ability to achieve certain performance or cost metrics?
All of the products we're developing can come in a variety of form factors. So we can do cylindrical, we can do pouch cells, we can do prismatic cells. Those are the kind of the big 3 form factors that are commonly used. And form factor has certainly some impact on the performance, but I think by and large, certain form factors are preferred because of interoperability with other designs, because of vehicle and pack manufacturing considerations. So for example, cylindrical cells are usually smaller, which means that they're more interoperable, and there's sort of, it's more of a standardized format, but it also means you have more weld points when you're actually assembling the pack, more points of failure potentially. On the flip side of prismatic, you can have very, very large cells, but then that means that the sort of this consistency of each individual cell has to be higher, and then how you actually weld it into the car is different. And so I think largely form factors are chosen based on more of sort of very practical engineering considerations at the vehicle level, and less about the cell chemistry specifically, although there are notable exceptions. So certain cell chemistries that have more mechanical swelling or volume expansion during cycling would be more appropriate for a pouch cell form factor rather than a wound cylindrical cell, say.
Certainly. Yeah. When you guys are asking the AI that you've trained what type of results you're looking for, are you inputting different variations of form factors when asking it to do its work?
Not currently, because that's pretty much specified by the customer. Usually they have a particular form factor that they need to work within because of, again, how they've designed their pack. For kind of longer term conversations where we're not fulfilling an immediate vehicle need, but we're maybe thinking about, a model year, a few years down the line, then we can have those kind of conversations and discuss the pros and cons and build that into the optimization process. But usually that part is already fairly constrained. So the AI process is really optimizing basically everything that's inside the cell stack. So the electrolyte, the electrodes, the active materials inside there, the inactive materials inside the electrodes, the additives, conductive additives, solvents and salts, and the electrolyte, and really helping navigate this very, very, very large design space of possible battery materials. That's the thing. The form factor, there's only a handful of form factors, so it's easier for a human to really design and wrap their head around.
Sure.
We're focusing the AI on the parts of the battery where there's an enormous design space, and it's very hard for a human to really consider all of the combinatorial, all the options available.
Certainly, there are so many types of minerals and different things that could be used. I'm assuming that the primary reason why a lot of them aren't is either due to performance or cost.
No, that's absolutely right. And that's why when I was talking about sapphire and jade and opal, those, as you go in that direction, they contain less and less of the sort of scarce minerals. So I would say most people, when they talk about battery chemistries, they focus on the active materials, and usually it's the cathode. So NMC is describing cathode with nickel, manganese, and cobalt. LFP is a cathode with iron and phosphorus. And but there's a whole host of inactive materials that are essential for making this work. You can't just have NMC just sitting there in the cathode by itself. The battery won't function. So same thing with the electrolyte, which is a whole very wide design space of chemistry in and of itself that's usually not mentioned, but has a huge impact on performance. So it's really, the goal is to have the best of both worlds. It's to have the cheap minerals, but then the complex combinations of the other ingredients in the battery that make that possible. So ideally what you would want is a battery that's just made out of dirt, but that dirt works because of all of the of the entire formulation of the system.
Tell me that the AI has returned some results that involve dirt, because that would be awesome.
Not literally dirt, figure of speech, but yeah.
I understand. For the prototypes, the sapphire and the jade that are ready for shipment today, as the website says, do you guys have current customers that are applying this and using your technology in certain types of vehicles, whether they be cars or anything else?
Yeah, so we have shipped prototypes of both of those products to multiple customers so far. This has been an effort over the past couple of months. And of course, different customers have different use cases and different kind of testing requirements that they're undergoing. But the feedback generally has been positive. And we're taking, of course, their feedback and then incorporating into the new designs and optimizing the chemistry for those specific applications. So yes, we've shipped prototypes. They're in customers' hands. We're getting, we're learning what that new performance is enabling for them, and we're learning, where they need an improvement, and where it's already, more than sufficient, and designing the next batch.
That is very exciting. At what point, and this is going to be hard to say, and maybe you won't actually have an answer, but do you think you can give a ballpark estimate in terms of what point the average consumer might be interacting with a product that is using the results of your work?
Yeah, so I would say first of our batteries designed by the AI process should be in vehicles sometime in the first half of next year.
That's awesome.
And that will be, those will be for one of our customers who are working on developing a more sustainable battery chemistry for them. It's a variant of the Jade family. So yeah, that'll be super exciting.
Are you able to give any information outside of just the generic customer? Like, will we see that in a certain region in the world? Like, will it be primarily China? Because of course they have the biggest EV market. Or here in North America, will we kind of see something on our shores?
Yeah, we're working with customers all over the world. One of the ones we're working with is based in the US, but we have other customers elsewhere as well. So who in terms of who gets the product out first, I guess I don't know, but yeah, it's not just localized to one area.
Yeah. Well, and that's great, because the process of using AI to save time is so significantly important. And at a time right now where we're going through such a massive transition in terms of fuel type, battery electric vehicles are very integral to that process. So anything that can be done to shorten the time frame to get new and better technology introduced, I think is absolutely fantastic. So, Jason, this has been enlightening, and I can't wait to see what you all come up with in the future. Thank you for taking the time out of your busy schedule to chat with me today. And if you, dear listener, want to follow Chemix, you can go to their webpage. It's chemix.ai, and Chemix is spelled Chemix. Alternatively, you can follow them on LinkedIn or Twitter as well at Chemix Batteries.
Thank you, Zach.
So I hope you enjoyed this chat with Jason, but we're not finished yet with this episode, so stick around and I'll be right back right after this.
Do you own a business and want to reach EV owners and people interested in electric vehicles? EV Resource is welcoming businesses nationwide, both big and small, to become advertising partners with us across all platforms. The EV Resource podcast, magazine, YouTube videos, social media, and our webpage. For more information, please email Zach at hello@ev-resource.com.
All right, what an awesome company. And I just can't wait to see how they evolve over time and what impact that they're going to have on the industry. I mean, 2 years old, they're just really just getting started. So it's time now for the question of the week. And yes, that's right, it's back, mainly because we have time in this episode for it instead of running well over an hour. So I'm wondering, what predictions do you have for how AI will impact the auto industry? And it doesn't have to be EV specific, although naturally, being an EV podcast, I would recommend that. But it can literally be anything you can think of. The sky is the limit. I will have the question of the week posted to the EV Resource Patreon page, publicly available, so you do not have to be a current Patreon supporter to participate. And if you so choose, you can also share your response and your thoughts by calling into the EV Resource hotline. And that is super easy to do in two ways. You can use your smartphone's built-in voice recording software and record your message, and then email that file to me at hello@ev-resource.com. Or you can call in on the EV Resource hotline toll-free anytime, day or night, and the number is 1-844-387-2428. Again, that's 1-844-EVR-CHAT. And if you know someone special with an upcoming birthday, anniversary, graduation, or some other special occasion, you can give them a gift of recorded voices from friends and family telling them why they're special. These recordings can be podcasted or put onto a keepsake. So visit lifeonrecord.com or follow the link in the show notes to learn more. All right, so that'll about wrap it up for this week's episode. But before I end, I do want to thank the Patreon supporters, especially Rajeev, Narayan, and Andy Cooper at the director tier, and Christopher Lawrence at the executive producer tier. And as always, thank you to everyone that supports me on Patreon. There are stacked benefits depending on what tier you're looking at. So I would encourage you all, if you're on the fence about supporting my efforts with the EV Resource, definitely head over to the Patreon page and check out the different tiers. It's entirely optional, of course, but super appreciated. And if you're not quite ready for that, I do have a few other ways that you can show your support. Instead of using mandatory membership fees or paywalls and putting everything I'm doing behind closed doors, I want to keep the podcast completely free. So I'm using advertising and affiliate connections to do that. So I encourage you to please consider supporting the sponsors and other organizations who make EV Resource possible. You can find a full listing of coupon codes and special deals from these organizations on the EV Resource webpage if you go to ev-resource.com/deals. As always, I invite your feedback for the show via email to hello@ev-resource.com. And that is it for this podcast. So thank you so much for being with me, and I'll catch you next week.